Hi, everyone. I just want to make a video that clarifies how to do transcription and translation when you're given the coding strand as well as the template strand. So in example 1 here, we have the coding strand. That's the strand that contains the actual code, the actual instruction on how to make the protein. Right? So when you do transcription, when you make the RNA, your RNA should have the same information as the coding strand. Okay, so when you have the coding strand, the messenger RNA is going to be exactly the same as the coding strand with one key difference. That is, the thymine will be replaced by uracil. And the reason for that is because there are no thymine on RNA, right? So all the thymine is going to be replaced with uracil. Other than that, everything stays the same. So over here, ATG will become AUG. CCG will stay exactly the same. And then ACA will also be the same. And over here, TGA, we will once again replace the T with the U. That will be your messenger RNA. It's the exact same thing as the coding strand, but the T is replaced by U. And then we can go ahead and do the translation. And we need the codon chart, which will always be given to you on a test or on a quiz. So we want to look up AUG. You might remember AUG as the start codon. And just, to be safe, I'm going to go through how to use this chart again. The first codon you will find in this column here. So that's the A. And then the next nucleotide in the codon, it's a U, right? So the A row and the U column intersects here, right? So it's one of these 4 things that we want. And then the last nucleotide in the codon is a G. So G is over here. So AUG, that means it is the MET that we want for the first codon. Okay. For the next codon, it is CCG. So let's try that one more time. So C and C, that means is this box that you want. And we want the G, right? So over here, you trace it across, you will see it is the pro, right? So that's the next one. ACA. So A, C, and then A. It's going to be THR, and then UGA, which is one of the stop codon, UGA, right? And then we write stop. That's it. Now, example 2 here, you are given the template strand. Okay? The template strand is the strand of a DNA which the RNA polymerase is going to use to build the messenger RNA. Okay, so when you have the template strand, what you should do is you have to find the complementary nucleotide. Okay, so what does what does T pair with? T pairs with A. What does A pair with? Well, A pairs with T, but because we are talking about RNA, we don't have T. We have U instead. C pairs with G. G pairs with C, another C, and then A will go with U. CCA will now become GGU, and ACT will be UGA. The relationship between the template strand and the messenger RNA is that they are complementary to each other. But one key important thing, again, is you don't use thymine. Every time you want to use thymine, you have to use uracil instead. Okay, so coding strand and messenger RNA, they are identical, but T becomes U. Template strand and mRNA, they are complementary. And then you would just do the protein like we did. So AUG. In fact, you should pause the video right now and see if you can figure out the amino acid yourself. Okay, so AUG is MET. CCU is another pro. GGU GGU is GLY, and UGA is another stop codon. Okay, it's just like that. Okay, very simple. Right, you should try these examples on your own again. Make sure you understand the relationship between the coding strand and the messenger RNA, and on the other hand, understand the relationship between the template strand and the messenger RNA. So I hope this was helpful to you. That's it. Thanks for watching.